going to be talking about graphing radical functions. This is Chapter 6, Section 3. So when I have you graph the function, you're going to identify the domain and range of the function. And we're going to do this by using a table of values. So we're just going to put our x, square root of x minus 5, then y. Table of values. Now we have to be really careful when we use a table of values of which values of x that we can put into this, into the x values, the numbers. We're putting in numbers or values into a square root, so we can't have any negative numbers. So I would also like to pick perfect squares. So I'm going to do 0, 1, 4, and 9. So you have to be really careful of which numbers you choose for these to get a really good, nice number. So we have the square root of 0 minus 5, the square root of 1 minus 5, the square root of 4 minus 5, and the square root of 9 minus 5. So that's going to give us a negative 5, a negative 4, a negative 3, and a negative 2. So let's graph that. So we have 0, negative 5, 1, 2, 3, 4, 5, okay. 1, negative 4, 4, negative 3, and 9, negative 2. So it's a nice little curved right there. And our domain has to be x is greater than or equal to 0. And our range is y is greater than or equal to negative 5, our domain and range. Okay, let's do another one. This time we are using a cube root, but we have it in a fractional form. So we can rewrite this as the g of x equals a negative 3 cube root x minus 1. I feel like that's much easier to put into a table of values than using a rational exponent. So let's do a table of values. X minus 1 and y. Now I want to choose a number, the first one, of what value do you plug in for x for a 0 to be underneath that radical, and that's a 1. So now we get a negative 3 times 0. So that's 0, because 1 minus 1 is a 0, and the cube root of 0 is 0. So the other numbers I chose was a 2. So 2 minus 1 is 1, and the cube root of 1 is 1. And then I chose 0 as well, because we can have a negative underneath the cube root. We can have a negative. So 0 minus 1 is a negative 1, and the cube root of negative 1 is negative 1, so we get 3. So we can have negatives if it's an odd root. So I also chose 9. 9 minus 1 is 8, and the cube root of 8 is 2. So we have a negative 6, and I also chose a negative 7 because that gives us a negative 7 minus 1, which is a negative 8, and the cube root of negative 8 is a negative 2. So that gives us 6. So we can graph this. 1, 0, 2, negative 3, 0, 3, 9, negative 6, 1, 2, 3, 4, 5, 6, and then negative 7, 6, 1, 2, 3, 4, 5, 6. Okay, and then we are going to follow that, okay? And then our domain is all real numbers. And our range is all real numbers. All right. Now let's look at the next one. Okay, this one is a little different. It says describe the transformation of f represented by g and then graph each function. So we're going to look from the f of x equals the square root of x to the g of x, which is negative 2 times the square root of x minus 1. Let's describe the transformations that's going on. There's a negative in front of the function, so that's a reflection in the x-axis. We have a 2 in front of the function, so that's a vertical stretch by a factor of 2. And then we have a negative 1 underneath the function, so that's a horizontal translation 1 unit to the right. Okay, and we actually can graph these to see if we're right or not. So let's do the parent function in black. So we have the square root of x and then y. Of course, I'm going to use 0, 1, 4, and 9. So 0, 1, 2, 3. So let's graph that in black. So 0, 0, 1, 1. Oops. Let's try that again. 0, 0, 1, 1, 4, 2, and then 9, 3. Okay, then let's graph our next one. Let's do that in red. Negative 2 square root of x minus 1, and then y. So I have 1, 2, 5, and 10. And we get 0, negative 2, negative 4, negative 6. Okay, so let's graph these at 1, 0. So already horizontal translation 1 unit to the right, that's correct. 2, negative 2, 5, negative 4, and then 10, negative 6. And that, oops, is also, it is a reflection in the x-axis, and it has been stretched by a factor of 2. Okay. Let's move on to using our graphing calculator. All right, this one it says, use a graphing calculator, graph the equation of the parabola. Identify the vertex and the direction that the parabola opens. Well, when we put something into the graphing calculator, we always plug it into y equals into our calculator. So that means we have to isolate our y. So let's do that first. We divide by 3. So we get y squared equals x over 3. And then we have to square root both sides. And when we do that, we have to remember to do plus or minus. So y will equal the square root of x over 3 and negative square root of x over 3. I separate this. You'll see why in a minute when I plug this into my calculator. Okay, so now we're going to plug this into the calculator. We're going to go to our y equals. And our first one we're going to plug into is we're going to do the square root of x divided by 3. And on the bottom one, we're going to do a negative, make sure it's a negative, not a minus, a negative square root of x divided by 3. And then we're going to graph this. You're going to see both sides of this, and the vertex is going to be at 0, 0, and it opens right. So the vertex is 0, 0, and it opens right. All right, let's do another one, but this one is going to be dealing with a circle. Okay, same thing. Use a graphing calculator, graph the equation of the circle, identify the radius and the intercepts. Well, we have to isolate the y. So what we're going to do is we're going to subtract by x squared. So we have y squared equals a negative x squared plus 4. Square root both sides. We do plus or minus. So y will equal the square root of negative x squared plus 4. And a negative square root of negative x squared plus 4. So we're going to put those two equations into the calculator. So we're going to go to y equals, and we're going to clear both of these. So we're going to do the square root of a negative x squared plus 4 and a negative square root of a negative x squared plus 4. And we're going to graph this. Okay, and if you want it to make it look a little bit more circle, we can go to zoom square, which is 5. And it'll look a little bit more of a circle. Now, the center is at 0, 0. So to find your radius, you count from the center to the edge of the circle. So this is going to be 1, 2. So the radius for this is 2. And the intercepts are at where it hits all of the axes. So it's at 1, 2, 3. There's 4 of them. So the intercepts are at 2, 0, negative 2, 0, 0, 2, and 0, negative 2 for that circle.